Okay. Any that you'd like me to go over? Any that I could help you with? Number 4? You got it. Number 4. Hey, can you all decipher when you just look at it that you know that you're going to have one solid line and one dotted line?
Yeah, with the underline.
Yeah, the underline inequality means it's solid when the inequality doesn't have an underline. Not, right? All right, so we're just going to draw best we can a graph. So I'm going to take a look at this one. We'll do this one in blue. Sound good? What can you tell me about the blue? What would the y-intercept be? Yeah, 0, 3. So y-intercept, that's my first point. That's where I start. So up 3. Agree? What is the slope of that line happen to be? Yeah, -2/1 is the slope. So from this point, I'm going to go down 1, down 2, right 1. Oh, because I went down. The down is the negative direction, so left is negative as well. So I only have to do one of the negatives.
That's 1 over negative.
I thought if it's positive, you go up. I mean to the right.
But
If you put it on this side of the axis, then it would be positive.
yeah, so if I have -2/1, that means I'm either going to go down and right, or I could go, if it was like this, I can go up and left. Now watch this, ready? If I go up 2, left 1, do they appear that they're on the same line?
Yeah.
Yeah. See how that works? Cool. Hey, is this one solid or dotted? Solid? Cool. Good so far? All right, let's do this. I'm gonna go with pink. I like pink. All right. Okay. All right. What can you tell me the y-intercept of this line would be? 0, 1. So it's right there. What is my slope? 1/1. So from this point, I'm going to go up 1, right 1. And this line is dotted. Cool? All right. Does it appear that 0, 0 is underneath the whole thing? You think this is a pretty good test point? So we're going to test this. I could test any point I wanted to. The reason I picked 0, 0 is zeros are easy to plug in. You know, you get the one kid who's like, I'm going to plug 5/4, 2.77 in. Okay. You're working too hard. All right, so I'm going to plug it in here. So that's going to give me 0 is greater than or equal to -2 times 0 plus 3. So 0 is greater than 3. Is that true or false? Yeah, it's false. Okay, so this was what color line? Which one was this for? Blue or pink? How much? Blue? So that means I'm going to shade on this side of the blue. Okay? Does everyone understand why I shaded the other side of the blue?
Yeah.
Do we know what side of the pink to shade on yet? No, not yet. So I'm going to do this one in red. So we'll do this. I'm going to plug 0, 0 into this one. So I'm going to get 0 is less than 0 plus 1 is 0 less than 1. That's true, right? So that means on the pink line, I'm going to shade the side of the pink line that the 0, 0 is on. So I'm going to shade down here. Where does the solution take place? Yeah, it takes place in this region. This is the region that our solution exists. If I picked any number in this region, any ordered pair, it would give me a true statement on both. Okay? Anything else I could help with on there? Anything else? Yeah. 6? Okay. Number 6. 2x plus 3y is greater than 6. Negative x minus 3y is less than or equal to 2. How are these ones set up to graph? Yeah, both the x and the y are on the same side, so I'm going to use the cover method. So I'll do this one in purple, or I meant to go purple. Purple-ish. So I'm going to go 0, comma, blank, blank, comma, 0. All right, this is an x value, so I'm covering this up. So 3 times what number gives me 6? 3 times what number gives me 6? 3 times what number gives me 6? 2. So 0, 2. And then this is a y value, right? So 2 times what number gives me 6? 2 times what number gives me 6? 2 times 2 is 4.
Oh,
3. 3, 0. All right, solid or dotted, friends? Dotted. Does it appear that 0, 0 is definitely on one side of this line?
yeah.
Cool. And I've actually seen these done where students will shade right away. You know, shade, and then they'll figure out the overlap region. All right, let's try this one. How is this one set up to do? Cover. So 0, comma, blank, blank, comma, 0. So that's an x value. So that means I get negative 3y equals 2. So y equals negative 2/3. Okay, so that's not quite as nice to graph, but we'll make it work. So 0, negative 2/3 is like here. And then this one will be fine. If I cover up the y, negative x equals 2. So x has to equal what? If negative x equals 2, if we multiply both sides by negative 2, good. I get negative 2, 0, which is here, roughly. Solid or dotted here? Solid? Let's see. Solid. So this is kind of doing one of these. Kind of like that. All right, so they cross kind of way off to the right. Agree? Okay. 0, 0 is definitely a good test point because it's right in between them right now, isn't it?
Yeah.
All right, so we're going to take 0, 0, plug it into this one. The nice one is when you do the cover method, what's 2 times 0?
0.
What's 3 times 0?
0.
What's 0 plus 0?
5.
Is 0 bigger than 6? No, that's false. So that was on the purple line. So I'm going to shade the opposite side of the purple. I'm going to shade up here. Okay. Now, let's go back to our buddy pink. I like pink. All right. I can do the same thing on the cover method on this one. Negative 0, 0. Negative 3 times 0, 0. Is 0 less than or equal to 2? Is 0 less than 2? Yeah, so that's true. Okay, so on the green one means I'm going to shade the side. I'm going to shade the side that the 0, 0 is on. All right, so this looks like my feasible region. That's where my solution lives. Okay? Again, if I picked any point up in that region, I plugged it into both equations, it'll give me a true statement. Hey, friends, can I move on? Okay. So, you don't really have to take too many notes on this. Let's just kind of watch. What would this look like if I were to graph these?
to the X, to the thing, positive 3,
Positive 3 on the X.
and then graph it up,
Is it solid or dotted?
solid,
So notice I have a vertical line. Agree? And then how do I graph the other one?
go to a Y to the 4, and then do a dotted line.
Go on the Y to the 4. Oops, make that green. Make that green. 1, 2, 3, 4. And this will be a dotted line. All right, so how do I justify 0, 0? I'd say 0 is left bottom of this graph. Agree? All right, so if I plug 0, 0 in here, I get 0 is greater than 3. True or false? False. Okay, so that's for the blue. So that means I'm going to shade this side of the blue. Then I'm going to take 0, 0 and plug, or just 0 and plug it in here. So I get 0 is 0 less than 4. That's true. So for the green line, I'm going to shade the side of the line that the 0's on, which is the bottom part. Friends, where does the solution appear to be? Yeah, this is where the solution lives. Lives down here. Okay? So that's kind of a special case you might come across. Now, let's see what happens here. Can I move off this screen? I know I just kind of talked about it, didn't really lecture it. I just want to show you two special cases. But let's think about this. Let's say I had 3x plus 2y is greater than or equal to 10. And let's also say that we have 7x minus y is less than or equal to 4. I don't want you to graph it. I just want you to be able to tell me, is the point 10, 3 part of the solution? I like the possibly. Okay, so again, we're not really taking notes. We're just kind of looking at it. So what are some ideas that we might be able to do if we're not going to graph it? How would we make this work? Yeah, I like it. We're going to plug it in. Okay, so this is an x, this is a y value. So I'm going to plug it in here. So I get 3 times 10 plus 2 times 3. We want to know if that's greater than. So it's 30 plus 6 greater than or equal to 10. Is 36 bigger than 10 or smaller? So it works here. So right now, 10, 3 is the solution to the top answer. Okay? Then I'm going to take 10, 3 and plug it into the bottom one. So I get 70 minus 3. 70 minus 3 is 67. Is 67 less than 4? 67 less than 4? No. So is the point 10, 3 part of the solution set for this system of equations? No. So this was false here. Okay? If they were both true, 10, 3 works. If they are both false, 10, 3 doesn't work. If one's true and one's false, 10, 3 does not work for the solution. Okay? Does that make sense? And the big thing to remember is when you have a point, it's x, y. Okay? So if you have only an x variable you're trying to test, you use the x value. If you only have a y value you're trying to test, you use the y value. All right. You ready? You have a lot of time to work on page 221, 1 through 11. You can do page 222 if you like, but it's up to you if you do it or not.
Oh, wait, I see what you're doing. Because tomorrow's homework might be.
No, bro, it's probably a brain thing.
222 is blank.
Tomorrow? No.
Well,